Hi everybody. So we've gotten practice with normal unit conversions, normal dimensional analysis, but it turns out that sometimes we have units that are derived, or they're different combinations of some of the base units that we've discussed. And so that makes things a little bit different, and we're going to see how that comes into play in calculations. And we may even see a situation where we have two different types of units. So for instance, miles per hour, right? A distance over time, or density is mass over volume. So we'll play around with those types of things and try them in some problems. In number one, we are interested in finding the number of cubic centimeters in 1 meter cubed. So our given is meters cubed, and our unknown, what we're trying to find, is centimeters cubed. And as a reminder, we know something. We know that there are 100 centimeters in 1 meter. But here's the thing, there are not 100 cubic centimeters in 1 cubic meter, right? So a cubic meter is, obviously you know this, but it is a meter by a meter by a meter, but it's also a meter deep on all sides, right? So that means that you can fit a whole lot of little cubes that are 1 centimeter by 1 centimeter by 1 centimeter and a centimeter deep, and obviously this is not to scale at all. But you can fit a whole lot in. So what you can actually fit in is 100 cubed centimeters cubed in 1 cubic meter. And the 1 can be cubed, but 1 cubed is still 1. So the easiest way to say this is if you cube the unit, you cube the number. So let's try this. We're going to start out with, we're going to start out with 1 cubic meter. And I'll set up our fraction. So 1 cubic meter we know needs to cancel out. So we will be putting cubic meter on the bottom of the next line. And our goal here is to get to cubic centimeters. And we know that our conversion is that there are 100 centimeters for every 1 meter. But we obviously have these cube things here, so if we cube the unit, we must cube the number, and you can actually write the cube number just like that in your equation. If you want to do the math and realize that 100 cubed is 1,000,000 and write in 1,000,000, feel free. But if you want to leave the cubed value like so, feel free to do that as well. You'll notice that our units canceled. We're left with cubic centimeters as our ultimate unit, and so when we do this math, we will get 1,000,000, or 10 to the 6th. I'll just write out 1,000,000. Cubic centimeters. Notice also that we started at the beginning of the problem with 1 sig fig. There it is. So our answer here has 1 significant figure. All right, let's make things a little bit more difficult. If you think you get the hang of it, definitely pause and try number 2 on your own, because things are a little bit more tricky when we get down to number 2. So if you've had a chance to pause number 2, let's define what we're looking for. We know that we have 370 cubic millimeters. We are after a volume of microliters. And we know some conversions. So first off, it's a little bit strange that we are given a volume here in liters, microliters really, and a volume here in a cubed distance, right? So there must be some sort of conversion to go between a cubed distance and an actual volume measurement, and that is that there is one milliliter in 1 cubic centimeter. So that's going to be our link to get between this, cubed value that we have here and this value that's just a straight up kind of volume. So let's start with what we know. We'll again make our fraction line. Here we go. We know that we have 370 cubic millimeters. We know one thing for certain, which is that we need to cancel out that cubic millimeters. So we're going to put cubic millimeters down here on the bottom to cancel out in the denominator. And we're on a journey to microliters. We know that on our journey to microliters, we must go through this conversion. So in order to use that conversion, we need to get millimeters turned into something else. Now, we might try to turn millimeters into milliliters, but you'll notice that this is a cubed volume, and this is a cubed volume. So our best bet is going to be to get to millimeters to centimeters. Now both of those have prefixes, so we know that we shouldn't do this directly. We should take our 1,000 millimeters and go back to our base unit of 1 meter. But remember, these are cubed millimeters, so these need to be cubed meters, and if we cube the unit, we have to cube the number. Again, you can do the math or you can leave it like that. Next up, we know that we need to get to centimeters to use that conversion up there. So we know that there's a conversion between meters and centimeters. In fact, there are 100 centimeters in 1 meter. But remember, your meters up top is cubed, so this better be cubed, which means this centimeters better be cubed. And if you have cubic centimeters, you darn well better cube your numbers because you've cubed your units. Now we have cubic centimeters, so now we're in good shape. Let's take time out. Let's cancel out the units so far. Millimeters are gone, cubic meters are gone. We're left with centimeters. We know that centimeters is our trick to turn into millimeters because we know that there is 1 cubic centimeter for every 1 milliliter. So let's plug that in here. Cubic centimeters on the bottom, so it cancels out. And we're going to 1 milliliter on top. Now these numbers don't need to be cubed because we're kind of getting out of cube units here. And 1 cubed on the bottom is 1 anyway, so it wouldn't impact anything. But milliliters is a good place to be because now we have liters, and liters is ultimately what we want to end up with, except they are microliters. And again, both of those have prefixes, so again, we have a little bit more work to do. Right now we have milliliters on top. We better cancel out milliliters on the bottom. Let's do that, but we can't go direct to microliters because we don't know how many milliliters are in a microliter. So we'll go back to the base unit by knowing that there are 1,000 milliliters in 1 liter. And then finally, at the end of the day, we can turn into our target, which is microliters, because we know that in 1 liter, there are 1 million or 10 to the 6th microliters. So if you come through and you cancel your units, you'll notice that cubic centimeters cancel, milliliters cancel, liters cancel. We're left with microliters, which is where we want to be. There's a lot of math here, but if you multiply all of your numerators together, multiply all of your denominators together, and divide and do the math, you will end up with the exact same number, 370. But now we've changed the unit from cubic millimeters to microliters. So it turns out that a microliter is the same as a cubic millimeter. This would have been a lot easier if we just told you that from the beginning, but oh well, we had a good time doing it. And as a reminder, sig figs, we started with 2 of them, we ended with 2 of them, so we are where we want to be. This looks like a whole lot of work, but you'll notice that each individual step isn't bad, right? You know your metric conversions, we're giving you those. All you need to do is keep your wits about you, make sure that your units cancel, and as long as you keep working towards your target, eventually you'll get there. As long as your units cancel and every single one of your conversions is true, i.e. the numerator and denominator are equal, then you're in good shape. Let's try one other type of problem. So we're going to look at the rotation of the Earth at the equator, and it turns out that it rotates at the equator at a speed of 465 meters per second. And what we want to know is, what is that in kilometers per day? And so what's weird about this is that we're given an initial value that has something in the numerator and the denominator. But the good news is we're operating with fractions, right? So you have a fraction. And so you can actually set up your starting value like this, 465 meters for every 1 second. So here's the trick whenever you have a unit that looks like that, something in the numerator and something in the denominator. You should do one of those conversions first. It doesn't matter which one. So for instance, we ultimately want to get into kilometers per day. So meters ultimately needs to become kilometers and seconds needs to become days. I'm going to choose, just for the sake of doing it, to cancel out my meters first and turn it into kilometers, which is my end target goal. And I know the numbers that go in there, right? I know that there are 1,000 meters for every 1 kilometer. Meters now cancel, and check it out. You are left with the unit that you want in the numerator. We have kilometers up there. Now we need to cancel out seconds and turn it into days, but here's the trick. Seconds is currently in the denominator, so we need to put seconds in the numerator to get rid of it, and you know we're working towards days. So a unit of time that's between seconds and days is minutes, and I bet we know how many minutes there are in a second, or vice versa. We know there are 60 seconds in 1 minute. You may be clever and know how many seconds are in an hour, and that's fine. If you want to go jump straight to hours, we're just going to take the extra step here. Notice that your seconds cancel. You're left with minutes in the denominator now. So now we need to cancel that again by putting minutes in the numerator. How many minutes are in an hour? Well, there are 60 minutes in 1 hour, and your minutes will cancel. And why was that helpful? Because we know the relationship between hours and days. We know that there are, in 1 day, 24 hours. And our ultimate goal is to get days on the bottom. Your hours will cancel. And ultimately, look at what you have. This is really a good place to be because we have kilometers on top, it's not canceled out. We have days on the bottom, it's not canceled out. And we want kilometers per day as our final unit. So everything else works the same. We multiply the numerator, multiply the bottom, which is the denominator, and divide. And ultimately, you will get an answer here of 40,200 kilometers per day, which happens to be about the distance of around the Earth at the equator, right? Because the equator goes around once a day, the same spot does. And you'll notice that we started off with 3 sig figs. We ended with 3 sig figs. So things getting a little bit more complicated. Again, if you're struggling with any of this and you're kind of falling behind this process called dimensional analysis, definitely see us because we want to make sure we take care of that early on and build a really strong foundation here.